Hi, welcome to Advanced Physical Science. This is Physics Unit 3, Force on Newton's Law of Universal Gravitation. So the first questions we have is, if planets are in orbit around the sun, what force is keeping them in orbit? What force keeps the moon in orbit? Could those forces of gravity be universal? Well, Newton's law of universal gravitation was first discovered because if an apple was attracted to the Earth, then are all objects in the universe attracted to each other in the same way? And the answer was yes. Every object has mass and attracts every other object with mass. Newton realized that the force of attraction between two massive objects increases as the masses of the objects increases and decreases as the distance between the objects increases. Scientific notation plays a big part in this. Scientific notation is just a short way of writing really big, like 5 with 12 zeros behind it, as 5 times 10 to the 12th, or really small numbers, 11 zeros, and then the number 3, as 3 times 10 to the negative 11th. Use the caret button or your y to the x button in order to get this kind of exponent. On your formula sheet, you're going to want the formula, the equation for Newton's law of universal gravitation. It is F is equal to big G m1 m2 over r squared, where big G is the gravitational constant. It is the number 6.67 times 10 to the negative 11 Newton meters squared over kilograms squared. Masses m1 and m2 are the masses of both bodies in kilograms, and r is the radius or the distance between them in meters. F then would be the force measured in newtons. If you're finding the mass only and the masses are different, use that equation. If you're finding the radius between the two, use this equation. If you need to find gravity, use this equation. And if the masses are the same, you'll use this equation. Those do need to be added to your formula sheet as well. The law of universal gravitation is an inverse square law. That means if the distance doubles, the force would drop by a fourth. If the distance triples, the force drops by a ninth. Distance is multiplied by 10, the force would be divided by 100. We're going to be using a simulation to help you see and understand and actually do some calculation. First, be sure that you're in scientific notation and that your sound is turned off. Scientific notation, notice that these two objects, the blue object has a mass of 100 kilograms, the second object has a mass of 400 kilograms, and they are standing 4 meters apart. If they're standing 4 meters apart, then you can calculate that the force of gravity between them is 1.67 times 10 to the negative 7th newtons. Notice the ruler can be moved, the masses can be changed, and as the masses change, the distances change, you can actually get the calculation of the force. The law of universal gravitation says this: if Jimmy is attracted to Betty, not in that way, by their mass. Jimmy's mass is 90 kilograms and Betty's mass is 57 kilograms. If they're standing 10 meters apart, what is the force of gravity between them? Well, we know the force of gravity, big G, is equal to big G m1 m2 divided by r squared. Big G is 6.67 times 10 to the negative 11th. Mass 1 is 90, mass 2 is 57, divided by 10 squared, giving you a force of gravity between them of 3.42 times 10 to the negative 9th newtons. The gravitational force exerted by a uniform sphere on a particle outside the sphere is the same as the force exerted if the entire mass of the sphere were concentrated in its center. So the force acts on the center just the same as it does on the surface. A planet has a radius of 3,500 kilometers. That would be 3.5 times 10 to the 6th meters. And a surface gravity of 3.8 meters per second per second. What is the mass of the planet? Again, we're going to use the second mass as a mass of 1 because we're finding the attraction for any object on the surface as well as the mass of the planet itself. So mass is equal to Fr squared divided by gm1. The force is 3.8, radius is 3.5 times 10 to the 6th, which would be squared. Be careful with parentheses there. Divided by gravity, 6.67 times 10 to the negative 11th times 1. Doing those calculations, we would get 6.98 times 10 to the 23rd kilograms. Any two objects attract each other with a gravitational force proportional to the product of their masses and inversely proportional to the square of the distance between them. The force acts in the direction of the line connecting the centers of their mass. Thanks for watching.